We're here today. The speakers earlier took it lightly, and unfortunately, I'm going to drag you into bolts and notes, the nuts and bolts of tech, what we do here. So I'm going to talk about concurrency in that. And first of all, how many of you are Flutter developers here? Do you even know what Flutter is? Okay. How many of you have done mobile development at all? Right. But they say Flutter is going to conquer the world. How come you guys have not gotten into Flutter?
They're just trying.
Oh, they want native development. Okay. Anyway, concurrency is a topic that is not unique to Dart or Flutter. Actually, Dart kind of came quite late into the game with their APIs and structures. So long and short of it is that in case you don't understand much of what we'll talk about here for the non-developers, please bear with me. You can ask questions, you can come back later. But just, it will register in your mind that at some point in your past you learned about concurrency and it will help you in the future. So let's start with concurrency with that. First of all, who am I? I am quite ancient. Very old. I've been writing software for the past 20 years, professionally. And since then, I've written code in different languages. Started with VB.NET, with .NET 1.0, and since then, done the whole 9 years, right? PHP, JavaScript, and Python, and so on and so forth. I'm also particularly interested in DevOps, SysOps, GitOps, different names. They keep coming up with different names these days. Kubernetes, Docker, and the rest of them. But these days, I focus mostly on mobile development. Particularly native iOS development, but once you know one, you know there are others, except Android. Android is from hell. And of course, Flutter. So, what is concurrency? It's pretty much simple. It's just a big word for being able to chew gum and work. Or at least we claim we can chew gum and work. It means being able to do multiple things at the same time or simultaneously. At least that's what Oxford English Dictionary says. But we are not here for English lessons, right? We're interested in concurrency when it comes to software development. So concurrency in software development, in programming frameworks, refers to the mechanisms, the techniques, the tools that allow you to write software code that are smooth. You know, when you use iOS devices and you see how smooth it is, Android is terrible again. And being able to write code that flows as you work with it. It takes much more than just knocking up your computer and opening an IDE and writing your code. By default, the code that you even get in an IDE, it's not performant. So as you develop as a developer, as you move on as a developer, as you grow as a developer, you have to learn skills and techniques that will enable you to do a little better. So that is what concurrency introduces or allows you to achieve. So it allows you, it refers to techniques, the mechanisms that allow you to write code that can multitask, that can walk and chew gum at the same time. So pretty much with the advent of modern CPUs, when you go buy a computer, you hear quad-core, octa-core, and the rest of them. So when you have CPUs that are capable of running essentially multi-core CPUs are simply CPUs and CPUs and CPUs. Now that is a lot of processing power. So being able to write code to take advantage of that multi-core CPU, that is pretty much what concurrency is really about in a nutshell. So when we talk about concurrency, whether you're in Dart or whether you're in Kotlin or Swift, essentially there are key elements that come into play every time you talk about concurrency. One of them is thread. So let's look at it this way. When you launch a mobile app on your phone, automatically the operating system launches it into what is referred to as a process. So it's sort of like putting you in the room, putting code in its own process. The smallest code execution part is the thread. So essentially a thread has kind of executes the smallest bit of code that involves when you write your code. So when you write sets of instructions and sets of instructions and they continue to execute. So essentially that is what a thread is. A thread is simply a segment of a process, runs inside a process. As a developer, you probably would have heard single threading, multi-threading. It simply means Or a single thread is when you write code that runs in just one specific thread. And multi-threading simply means the operating system or this device you have, the platform you have, is able to give you channels, multiple channels to be able to execute your code and make it a lot faster. Now, I introduce those terms because we'll probably encounter them as we proceed. So, but like I said, what does concurrency really enable? So when you use mobile, you know, iPhone, when the first iPhone came out, it wasn't possible to listen to music while you browse or swipe to your phone, your pictures. It was pretty much single-threaded, so to speak. So you won't be able to use things simultaneously. But with evolution of the iPhone and even other small computer platforms, with multi-core CPUs, you are now able to do things like simultaneously swipe, listen to music in the background while you browse and stuff. So in addition to the hardware being provided, like the multi-core CPUs, the concurrency APIs or thread, which we'll talk about here, is what enables that to happen. But another thing, concurrency also enables better resource utilization. Essentially, when you have multiple execution points in the code base accessing the same resources, it can become a little bit of a problem, you know, like being able to reconcile grabbing the data here, grabbing data there. So, but what concurrency does is it enables it, makes it easier for you to utilize the same resources very, very efficiently. And ultimately, all this is just about offering you better performance. But careful now, as a developer, I'm sure, how many of you have really worked with concurrency in other platforms? Yeah, I know it can be hell. Essentially, you can write yourself into trouble. I mean, just like that guy. That guy probably woke up in the middle of the night and wrote that 10:54 p.m. Says async programming, which is pretty much another term for concurrency, is cool. But with just a few minutes of work, you would write yourself into trouble and throw your computer through the window. Okay. Sorry guys, I actually came with a wireless microphone so I'll be able to walk around, but that didn't work.
If you stand on this side, okay.
There you go. So we've talked about, I mentioned that concurrency, that is even a newbie when it comes to concurrency computing platforms. Kotlin, if you've been in Android development, you've worked with coroutines in Kotlin, and Swift is the concept of GCD, Grand Central Dispatch. And the new structured concurrency with async awaits, Java, C#, they all offer APIs or software development kit that allows you to write programs that are performant using multi-threading and so on and so forth. But today we're interested in concurrency in Dart. So it's unfortunate that we don't have a lot of Flutter developers here. Just like she mentioned at the end of this talk, if you are interested in specific topics, please note them down so that you'll be a lot more engaged in the topic that we talk about. Quite frankly, in the Google DevFest last year, there were lots of developers from Flutter and the rest of them, all full spectrum of Google toolkit. So that is where this whole idea came up from. I had a conversation with somebody who complained about Flutter not being really, in the company, they had an Android team, and at some points they wanted to port their application to iOS. So instead of hiring a separate iOS team and a separate Android team, they decided they would go with Flutter. Well, one of the pain points they encountered was being able to increase the performance of the application. Part of the application required them to track users' location in the background. Now with Android, the APIs, which is native, when you write native Android, you have tools and SDKs and APIs that allow you to do that, even though it's terrible, but I mean, you still have them. But with Flutter, it wasn't exactly very mature, but as Dart and Flutter has continued to evolve, they've introduced new concepts and new mechanisms with new opportunities like concurrency. So that is why I decided to talk about this topic. It is quite bleeding edge in its own way. So, whether you do Flutter, whether you do Android development, whether you do iOS, the way CPUs work essentially is maintain a stack, maintain a data structure, maintain like It's just like when you're in the office, you walk into an office and perhaps you have an inbox and an out tray and stuff. So when you come in, people stack in the documents you need to attend to, and they stack them probably in order of priority, or generally first in, first out. So that's what that FIFO stands for there. That is pretty much how modern CPUs or CPUs, central processing unit, your computers really process instructions and handle process tasks on your computer. So just about in Flutter, just about everything you do is an event. So when you click, even on a regular computer, when you move your mouse pointer, it is an event. When you tap on the keyboard, it is an event. So what the computer does is it creates this whole stack, this whole storage, or this whole mechanism to register. So it says, as you stack up, or as you perform this event, I'll stack it up and I begin to process them one after the other. So that is pretty much at the heart of Dart and mobile development, mobile applications or computer applications as you see them. So essentially what happens is, as the item goes in, as you perform an action, just like I push the button here, it goes into that queue and then it's sent into what is called an event loop. The event loop is what processes it. So, and it goes on until once it's done processing every task that is pending, it quits that particular thread. So that is pretty much at the heart of concurrency and at the heart of how the Dart processes or Flutter, as the case may be, or modern computer, our software systems or modern operating systems process the software that you write and the task that you perform. Now in Dart, there are concurrency primitives. Essentially what it means is that there are core elements that make up concurrency that allow you to write concurrent program in Dart. The two main ones, if you've written Dart before, is feature and stream. These are APIs that allow you to write data that makes your code a little bit more performant. So what a feature and a stream is essentially placeholders. How many of you have written JavaScript before? Yeah, so feature and streams are pretty much like, feature is pretty much a promise. So essentially it is like, I promise you in the future that this data will be available. So when you describe a type for a variable or something and say this is a feature of type T, you're simply saying that somehow I'm going to make that available in the future. Async awaits, just like JavaScript, if you've written JavaScript, modern JavaScript, allows you to write your asynchronous code in such a way that it looks like a synchronous code. Now, I feel quite sad. I don't know. How many of you are developers? Let's start again. All right, so you guys understand exactly what I'm talking about. So async await allows you to write code that looks like synchronous code, but it is async, so that way you're a bit more expressive. I tell you, even Swift on iOS, as much as I love it, writing iOS application, the day they released the async await concurrency primitive in iOS was probably one of my happiest days. Essentially, I'm a nerd like that, so it makes you write code that is just too elegant. Likewise in JavaScript, if you've written JavaScript before, you can get into, if you use callbacks, and even when you use promises, you can write yourself into trouble, the pyramid of doom. So async await simply means that you can just write your code and just throw in one or two words, which is pretty much that, async await, and you just keep writing your code and it's a lot neater. But isolate is the most important aspect of writing performance Flutter or Dart application. That's one of the most sophisticated API that Dart provides for writing it. So Dart on its own is pretty much single-threaded. Remember when I talked about single-threaded language? So unlike Java and C# and the rest of them, where they give you the language itself gives you native threading model, so you can dive deeper and create threads. Remember when I said the thread is just like a process, it's just like a tiny room. Like you walk into this place and you need a lot of space to do stuff, so the computer will give you a small space process, and then every code you execute is pretty much lined up for you, which is called a thread. So with Dart, prior to 2.7, I think, version 2.7, you didn't have access to being able to create multi-threaded applications. So you were stuck with writing applications that, at the best, uses feature and stream API to pretend to be asynchronous. So essentially, the feature and stream API, like I said before, is just like promise in JavaScript. What it does is simply promise you value in the future, and async await simply allows you to do non-blocking code. So they are not truly multi-threaded. They are concurrent. They provide you like asynchronous construct for writing your code. But isolate is what gets you closest to writing multi-threaded code in Dart. So it enables computations to happen in parallel. So imagine you get to a cafe, and you maybe a very popular one, and everybody queues up maybe in the morning, everybody at the same time. Imagine Dart or your application to be like that coffee shop, everybody in the long queue. Then imagine with the introduction of isolate or thread, like a multi-threading, you now have the ability to set up a new queue. So you can set up multiple queues and have multiple baristas attending to you at the same time. It moves a lot faster. So that is what isolate introduces. We'll get to isolate. Quite frankly, I actually wanted to make this talk about isolate because naturally, if you've written Flutter at all, you probably would use future and stream and the async await syntax. But isolate is one where not a lot of people have been able to get into. The syntax is quite arcane, it's quite difficult to grok. So like I mentioned before, there is in concurrency, there is async and there's parallelism. So async is, like I said, future, stream, async awaits. They offer you non-blocking code execution. So when you use, just if you've written JavaScript, it's pretty much the same concept. With future, stream, you just promise you will have a value in the future, then it simply says go on and continue executing whatever code thread you want, and once the data becomes available, we'll provide it to you. But with Isolate APIs 8, completely, you can create a whole parallel track. And what you do is, you just push it over to the parallel track and continue executing whatever it is you do. So let's start with future. Like I said, it's just a promise. So essentially, it represents a continuous asynchronous operation, rather than an asynchronous operation that promises you value in the future, and it usually exists in two states: uncompleted or completed. In an uncompleted state, usually when you declare your variable, it's pretty much indicated that, okay, look, this is what it's going to look like. In the future, I'm going to provide an integer value. But at this point in time, it is empty. It's almost like you have a box. Somebody gives you a box and say, sometime in the future, something is going to show up in that box. It belongs to you. So at that point, until that thing shows up, it is uncompleted. But in a completed state, pretty much okay. There are different APIs or different functions that allow you to create a feature. This is where it begins to become different from like a promise in JavaScript. So here you have a function that says fetch me a movie title. So pretend like it's fetching this movie title from the IMDb API, and after 2 seconds it provides you returns that are print Titanic, as the case may be. So essentially what happens is that if there was some other instruction at the bottom, you would probably continue executing it while this stuff waits till after 2 seconds and it provides you data. So it just simulates how long the wait it takes before your data is fetched over the network. Yeah, sure. Okay. So, essentially, when you execute a code like that, this is pretty much what happens. So it starts with fetching. Naturally, if you are used to writing synchronous code, you would expect that when you call this function, the first thing that should be printed will be probably Titanic, right? But of course, like you guys said, you are familiar with asynchronous programming in other languages. So the first thing that goes in there, fetching movie title and Titanic. So essentially, that is future. JavaScript, easy. Like I said, the future can complete can exist in two states, uncompleted and completed. And in the completed state, it completes with either a result, which we just saw in the last slide, or it can complete with an error. So for some reason, something happened, it will throw an error. So which is pretty much what happens here. So let's move on to stream. So stream, while a feature presents you a single value, a stream presents you a sequence of values. Now, in JavaScript, how many of you use generator functions in JavaScript? All right. So generator function simply is a kind of function where you run it, and unlike returning a single value to you can say, okay, I want this function to continue to run. Perhaps you're fetching the data from a socket, web socket from somewhere, and you want to just keep returning that data as it comes in. Imagine like you have, say, your chat, you're sending a message on WhatsApp or something. As the message comes in, it shows up on your phone. You didn't have to refresh it like you refresh your web browser, right? So somewhere in the underlying code, in, say WhatsApp, if someone had written it in Flutter or something, they probably use the Stream API. So what the Stream API does is probably it will use like a generator function or some other kind of function that generates or returns a stream. So stream, just like a feature, is a promise of future value, but at the same time it can generate a sequence of data, unlike feature which returns just one value in it. So there are different ways in Dart to create streams, and for example, surprise, surprise, Flutter also has a generator function. So you probably see the async with the asterisk there, and what it does is yield the values, and it continues on and on and on. So that's one way to create it. So the syntax is simple. So the return type is indicated, and the async notation there indicates that this is a generator function, and it is going to return you a stream of values. And it iterates and goes on and on. So here's a real-life example of using a stream. Now, throughout this presentation, I'm going to disperse code that you can use in real-life application and not just contrived examples. Say you connect to a WebSocket, like I gave as an example before. Stream controller is one way to create a data stream in Flutter. And the exciting to remember, the whole point of this is a concurrent. We're talking about concurrency. So the idea is that for some reason the application starts up, the rest of it will continue to execute. But the stream controller, the stream that it returns, simply whichever code that is listening to it somehow begins to receive the data, and everything continues to execute in the background. So here is one API for creating streams in Dart. So here the stream controller says, hey, you know what, I am expecting strings. So this is a box. It's expecting strings in the future, a couple of them. So this class, this object initializes, and it does all the magic it needs to do, but the key element there is the controller object exposes a method called add. So this is how you put in data into the stream. And once you put in data into the stream, you use the listing method to extract the data. This is not the exciting part, but I thought, of course, we would need to go through all the stuff to get there. For you JavaScript developers, you're liking Dart already. Yeah, it's getting there. I mean, I've written a large-scale application in JavaScript, and it was a pain until I discovered TypeScript, where I provided type in the system. Yeah, so when I moved on to Flutter, to Dart and stuff, it was like heaven. It's really exciting. So for some of you who've written, how many of you have been consigned to purgatory in writing PHP? Any PHP person there? Oh, sorry. So, yeah, Streams has its own API. So in addition to being able to generate streams, you will probably be able to listen to streams. So imagine that this is a WhatsApp app, and what is done is say, okay, I'm listening to every message that comes through over the wire, and when I receive the data, I print it out. So these are different APIs that the Streams data structure provides in Flutter. So, and so on and so forth. I'm actually hurrying up to get to the isolate part of it. So just like the future, it can return data, and at the same time it can also return errors. So when it returns errors, it provides simplified APIs for you. You get two different ways to receive errors from Stream API. One is using the cache error, one is using the try await. Yeah, I mean, if you've written JavaScript, this all looks familiar to you. Yeah. And async await is pretty much syntactic sugar over like Flutter and Stream. Like I said before, async await is the best thing for most programming languages since Sliceberg, I guess. So essentially what it does is it simplifies the syntax you use to write concurrent code. So rather than use the future and use the then and chain APIs or methods to get to your data, with async await, you just structure it almost like the way it reads, so it's a lot more intuitive to work with. So the thing with programming is, writing the code is the easiest part. It's maintaining the code that becomes the problem. I mean, you've heard a whole lot of those memes. When I wrote it, probably I and God and I were the only ones who knew what I wrote, but now I probably only God knows what I wrote. So the whole reason why we keep developers of programming languages keep evolving the programming languages and keep adding features like that is to make it easy for you to maintain your code base. When you start to write non-trivial applications that begin to expand functionalities and keeps growing, you run into problems where you suddenly look at your code. I've written a promise in JavaScript that's indented, like almost close to 120 columns. It just kept then and after then, and it kept going. But with async await, it simplifies it, so it's a lot easier to just go step by step and proceed. So Dart also offers that construct. All right, yeah, isolate. So isolate is just simply an abstraction over threads in Dart. So if you've worked with Java, like say C# and Kotlin in Android development, even on server-side development, you would need to be able to spawn threads, or create new threads and parallelize your processing so that your application will run faster. So I mean, if you imagine how web servers work, so when you type in www.cnn.com on your browser, it hits a web server that fetches that data and pushes it to the client. 1 million persons typing that address at the same time, like say ChatGPT, the website, it would overwhelm the server if you just have one thread handling all that processing. So, but what multi-threaded programming languages and frameworks provide is the ability to be able to say, as this comes, I'll just spin up a whole new computation, making a whole new computation segment or process or thread to handle this, and at the end of the day, we'll collate it together and feed it back to you. Of course, there are hardware limitations, but for when you'll be able to scale up your hardware device, your hardware, your CPUs, and those are available, you now need the software to run on the capabilities provided by this modern CPU to be able to spin up a whole lot of thread and handle it. So with Flutter, you probably will say Flutter runs on your device, so you don't need to spin up a whole lot of thread to be able to do stuff like that. But like, remember when I mentioned, when you build applications, things like applications that track your location and probably send your live location to someone else, you probably want it to run in the background. And being able to do that, and when you shut down your phone and put it in the pocket, and you know, that is what multi-threading offers, and that's what isolate really helps you achieve. Most people use Flutter, and they think it's easy. You can just talk about applications, usually for trivial applications. But when you start building non-trivial applications, when you start perhaps moving an application that was built, say a Twitter client or WhatsApp, those applications that you need to continue to run, even when in the background, when you shut down your application, that is when you go into the territory of isolate. So isolate is just an overlay, it's just an abstraction on top of threads. And we've talked about a thread, what a thread is before, a single execution in a CPU, in a process. Now each isolate has a thread and its own memory. So now, one very unique, smart thing the Flutter developers did was, in creating isolate, which isn't exactly a regular thread, one of the features, the key things they were able to distill from multi-threaded applications elsewhere, or one of the things they did to distinguish themselves from the multi-threaded application platforms and languages elsewhere, is to make sure that they isolate each thread. Now, one of the problems you run into when writing concurrent application in maybe C# or Java is being able to synchronize the data. So you have a task and you parcel it out into multiple threads, and then you need to sync it back together. Usually you run into problems like race conditions, deadlocks. You run into a whole lot of problems, data corruption. So sometimes when you use an Android application and somehow it corrupts your data, that is usually where the problem is. It's terrible. I promise you, it wouldn't happen on an iOS or a Flutter application. So, but we would isolate in Dart. What happens is it gives you every isolate. When you spawn or create a new isolate, just like you create a new thread, it comes with its own thread execution process, and it comes with its own memory. And they're all self-contained. So you wouldn't have if you spin out multiple isolates, you wouldn't have a situation where one isolate tries to read data that belongs to another isolate and share data. What happens is they can pass data between themselves using a process I'll get to later on, but it is usually immutable data. Now, I promise you, once you start progressing or growing your software development career, immutable data is the solution to most of all the problems you have. Being able to create a data structure that you can predictably mutate, you know where it is being mutated. I mean, if I've written code where it's almost read like a go-to statement from way back. You declare a variable, but suddenly it is being mutated from different angles, from different functions. You run into a whole lot of problems. So creating immutable data structures, which is pretty much why Redux became very popular, and a whole lot of Elm and other programming languages like them before. Pretty much what they do is create immutable data structures that allow you to be able to pass data without corrupting that data. Immutable data structure means that you can't change it. If you need to change it, it has to go through a central authority to be able to change it. It's pretty much the way you would probably come to a robot. If the robot doesn't work and people are not orderly, like in Lagos or something, everybody is trying to go at the same time, they end up corrupting the whole data. So with immutable data structure, it's a lot more predictable to say, okay, you have a responsibility here to mutate this data and no one else. So that is what isolate offers. So multi-threading in Dart, like I said, is pretty much enabled by isolate. So when you launch an application developed by Flutter, developed in Flutter, when you launch it, it launches into an isolate. Every code execution part in a Flutter application runs in its own isolate. Like I said before in the previous thread, isolate offers you a single thread, offers you your own memory space, and offers you your own, you can input, output, and share data with the rest of them. So the first isolate that launches when you launch a Flutter app or Dart app is referred to as the main isolate. So the life cycle is simple. It runs the main function. When it runs the main function, then it sets up the queue, the event loop and event queue. Remember when we talked about the event loop and event queue? Then it begins to grab events. When you push a button on your keyboard, it's an event. When your future, remember when I say future, it's a promise for data event in the future. Once the data becomes available in the future, it runs it through the event loop and it keeps processing it and it keeps going. So that is pretty much how Dart apps or Flutter apps work. They start in a single isolate called the main isolate. But here is where it gets exciting. If for some reason you need to begin to track a user's location, you can spin up a new isolate. When you spin up a new isolate, you pretty much tell it, I want you to do what, track a user location. Then it can use the APIs that are required to talk to your GPS radio to grab data and do what it needs to do. At this point, the application here, the main isolate, which is the main UI application you're looking at, can go into the background. You can put it in your pocket. The other isolate begins to run in the background. So once it's done computing its task, it can run continuously. Remember, you can still use your whole stream API to run the code in your isolate, and what it does is it generates data and sends them across the main isolate. But even if the main isolate is shut down, perhaps you close your phone or something like that, that's where the stream API, that's a whole different topic entirely. But the most important thing is that when you have these isolates or a background worker, a background thread or background worker thread, as it's referred to in different platforms, it just continues to process the events and it continues to wait for you till you come back. This is the part where people just simply get tired. I remember working on this large-scale JavaScript application. It's for a very renowned publishing company here. It was an ebook application. It was important for the ebook application to fetch data, do a lot of things with the data. Essentially, I wrote an ebook application in the browser, but it was important to the data comes in a different format, in HTML formats. We created our own custom annotation layer on top of it. So imagine a 2,000-page PDF comes back. You have created annotations and you've created annotations like highlights, scribbling and stuff. you serialize that data, you persisted it somewhere. Now you need to overlay all that data annotation you've created on top of the 2,000-page document that just came through. If you've written perhaps a PDF code like that, or even EPUB code like that to render and process that stuff, you soon realize that it sees, if you run it like in JavaScript, which is single-threaded too, it seizes up the whole browser. Have you launched a website or web app and somehow you keep tapping on the screen and nothing is responding? This is what happens there is because JavaScript, just like Dart, is fundamentally single-threaded and is doing a lot on that thread where it launched. So what then happens in JavaScript, just like I'll get back to it in Dart, or rather let's go to Dart. What Dart affords you with this isolate API is that it allows you now to create a background thread to say, for example, all right, go process the whole annotation. Once you've deserialized it from wherever it is and you've inflated the data and you're ready to overlay it, give me back the data. Now, but the painful part, the reason why I told that story was the painful part of JavaScript, which is pretty much what the isolate API offers. JavaScript offers the same thing. It's called a web worker. How many of you have worked with web workers there? Yeah, if you work with web workers, it is painful. So one of the reasons why it is painful is because you can't share memory, you can't share data between your main isolate. Remember when we talked about main isolate and this other isolate? So you can't declare a variable in main isolate and then probably do some processing and from there reach out into the main isolate to manipulate the data. If you need to pass data between them, you need to serialize it and pass it to the one thread, move it to the other thread, or worker as the case may be. So there are different APIs. The APIs available to create isolates. One of them is using the concept called receive pod. I promise you this is actually a little bit, or used to be a little very, very painful for me to even grok, using the whole receive pods, and I'll get to it. So let me walk you through it. So you have the main application. Usually in Dart, you always have a main function, which is the entry point into the application. So you have a main function, and you're trying to parse a JSON. So imagine this is an ebook reader. You've received the ebook from the server in the form of a JSON, a payload. You grab that JSON data, and like I said, you can spin up a whole new isolate or new thread, and you pass it that data, say go process this particular stuff, serialize it, overlay the annotation on the specific segment or div where it's supposed to be, and once you're done, give me back the whole serialized and annotated document back. So pretty much what isolates helps you achieve here. So you launch it, but to be able to pass data between each isolate, remember the main is a different isolate on its own. That comes standard once you launch an application. You have to create a port, a receive port, which is just a data structure that isolate provides, an API that isolate provides that allows you, it kind of defines how you pass the data from one isolate to the other. Once you define the port, then you use the API, the spawn, just like the word suggests there, you are spawning a whole new web, a whole new thread, a whole new isolate. And then you give it a function that you really need to do that parsing and give it the port. That port, like I said, is just simply a channel. It's like a tunnel that allows you, a wormhole that allows you to pass data between multiple isolates. And remember, here you probably see the parse, the read and parse JSON. That is the function here. So now this is pretty much what runs in the isolate. So what is happening here is that you've not given it, perhaps, in this case, it's reading it from a file system. It could be data you've already downloaded. It could also be data that you fetch from the network. And you've decoded it. This is where the main work happens, being able to decode the JSON data structure. I mean, it could run into a 1 megabyte payload size. And when you decode it and you grab the data, then the last part of it is how do you send back the data to the UI. Now, the exciting thing is when you learn to use the isolate API in Flutter or in Dart programming, just like in JavaScript, when you learn to use web worker, what happens is that you begin to write applications that are incredibly performant, which is the whole point of this whole talk. So now we've been able to say, don't process this thing on the main thread, don't process this thing on the main isolate, which is where the user, when you tap on the screen and you scroll, it is the application, the framework uses the main isolate to process those interactions, those events. Well, we say, okay, let's leave that, and then you spawn a whole new isolate, a whole new thread, and you pass your data to that new thread. And once it's done, what it does, it passes it back. So this is the API it uses isolate.exit, and you tell it, okay, here is the port, first of all, that is what that P stands for, and this is data that's been processed. It says, take it back. So essentially, this is what it looks like on the diagram. So you have the main isolate, it creates a receive port. Like I said, the receive port, you can just imagine that it is a wormhole connecting to places in space, like creating this structure that allows you to transfer data between two isolates. You give it the data you want, it processes it, and once it's done, what does it do? It returns the result to you. So now this begins to give you ideas of how, if you've ever thought about writing applications in Flutter, which is exciting. Look, initially I was quite skeptical about using Flutter for developing applications. I've always been a purist. I've always felt like if you need to write an application for a device or a platform, you use the tools that have been provided by the creators of that platform. So I went ahead and learned how to develop the iOS using native Objective-C and eventually Swift to write iOS application. For Android, learned Java and eventually Kotlin. But when I eventually went into Flutter, the syntax made a whole lot of sense. There was a little bit of performance issue initially, but like I said, with the advent of isolates and with some other performance improvements in the whole framework itself, it's gotten better over time. So these days you realize that it's possible to write very performant mobile applications on Flutter, and millions of applications have been written using Flutter. You probably wouldn't know you use them. Oh, guess what? Which is the most used app on your device at this point in time? Okay. You only use WhatsApp when you have electricity, isn't it? It's possible you don't have data. Or perhaps it's not the most used app. Okay, but one of the number one used app or downloaded app in South Africa at this point in time, who can guess?
TechTalk.
Eskom Sepush. We actually had him as a guest in the October meetup, so that's why you should really attend meetups, GDG meetup. So the guys who developed the Eskom Sepush, they showed up and told us, walked us through what they did and how they developed the application. So when you use Eskom Sepush, just know you are using the Flutter app, you're using the Dart app. So you probably heard me use the word interchangeably, Flutter and Dart. Not to confuse you, Flutter is a framework that Google developed for writing mobile application. But to write a mobile application in Flutter, you need to use a programming language called Dart. So that is why when this topic, I titled it Dart, which is essentially when you write Dart, when you want to write a Flutter application, you use Dart. So your Eskom Sepush app was written using Dart. It is a Flutter app, so it's exciting. So for some of you who aren't developers here or technical persons here who are probably in product management, it gives you an idea of what you can do in the future. If an idea comes up to develop a project or an app, a product, you can really get your developers to explore the possibilities of Flutter and what it offers. And I promise you, with the developments that keep coming, it gets better. So these are real world examples of how to use isolates now to develop applications. And this is a real world example of a code. I plugged it from a project I worked. So essentially this fetches weather updates. So most of you have apps on your phone with weather widgets. So even when you're not using the phone, somehow the data still flows into the phone and you can, it renders and continue. So that wouldn't have been possible in Flutter a while ago, but with the advent of, or with the invention or introduction of the isolate API, it now makes it a lot easier to write applications like this. So essentially, this is not a theoretical exercise, there is a practical value in it. And here's a sample web application. Here's another sample or example of using isolate where to improve the performance of the application. Well, quite frankly, it's hard to understand why somebody would want to decode and encode the video on their device instead of passing it into a server. But it's happened. People do it too for some reason or the other. In fact, when you capture a video with your phone or picture, it's somehow decoded into different formats on your device, though it happens on the native layer by the operating system, or rather, say for example, if you use an iPhone, it's the Apple developed the software, so they have access to even APIs that we don't have access to. But for some reason, you decide to write an application to decode and encode videos. You can do that in your mobile device, and if you try it without using something like an isolate, it will be completely unusable, the app yourself. But with isolate, you can be able to do wonders like that and develop very, very performant applications. Now, you probably would notice that API, the spawn and exit, this API we talked about here, it's a little bit of a head scratcher. Like I said before, if you use WebWalker in web development, the API is quite gruesome, very difficult to use. So what in Flutter itself, they have a different function or a different API that allows you to easily create isolates and makes it simpler. So it's just one function. I've highlighted it there, compute. So what it does is simply say, you can write this code. This is the code that will run in a background thread, and just say, then from your main isolate or your main code, you just simply say compute, and you pass in the function and the data you need to pass through to the function, and it goes ahead and spawns a new thread or isolate and performs your data. Now, some of you might know that Flutter, the reason why it's exciting, there's a lot of exciting development in Flutter, is that it is multi-platform. So you can develop both iOS and Android applications with Flutter, but you can also develop desktop applications, and you can also for Mac and Windows and Linux, and you can also develop for web. So that is why Flutter is really, really exciting. Like I say again, if you're not technical, but you're in product management, there is a very huge, big, serious case to be made for using Flutter and that for your next project. So, but even though it supports all these platforms, it is still not, some of those APIs that are available in some other platforms are not available in some other platforms, like for example web. I just described the spawn, the isolate API that allows you to create very, very performant application. But if you decide to write a Flutter app for web, essentially you write a web application, a website or something with Flutter, unfortunately that API is not available. So while the rest of the APIs, the feature stream, async await is available, but on that web, the API is not available, you have to use WebWalker, which is indeed very painful. But I understand that a new API is being developed for it, a new evolution is being developed for that would enable you to write APIs, use the isolate API in web. So essentially, in a nutshell, I could have done for this a little bit more technical than this, but it gives you an idea in the future to explore and go research and understand exactly how you can build more performant applications on for mobile devices or desktop applications using all these concurrent APIs available. If you want to ask more questions after this talk and you have ideas you want to share with me, feedback, you can always reach me there. Thank you very much for giving me attention here.